Many companies these days have absolutely massive text data sets, from emails, customer reviews, newspaper articles, and tweets. In the next 5 minutes, I want to tell you how you can extract invaluable insights from these data sets, and how you can do this quickly and efficiently. My name is Markus Kunisch, and I did my fellowship project with ASI Data Science. ASI applies artificial intelligence to real-world problems. One such problem is that in the age of Twitter and Facebook, opinions can spread like wildfire over the internet, and your company's online reputation can make or break your company. Sentiment analysis gives you a way of monitoring your company's online reputation and reacting immediately when it becomes necessary. But that's just one example. There are many other ways in which sentiment analysis can help your business. What a lot of these applications share is the need to be able to process large amounts of data very quickly. So in order to develop their big data sentiment analysis capabilities, ASI gave me the following challenge. Take the entire Amazon review dataset with more than 150 million reviews, create sentiment analysis models, and make these models as accurate and as fast as possible. This is too much data for standard Python libraries. So there are actually two challenges here. The first one is to deal with this large amount of data, and the second one is to find the best sentiment analysis models. But let's take things in steps and start with big data. As I said, standard Python libraries cannot cope with this large amount of data. So to solve this problem, I used Spark. With Spark, you can get many computers to work together on the task and get to the answer much faster as a result. That's not easy, but Spark allows you to do this. However, you cannot expect Spark to just give you, magically give you perfect performance out of the box. Indeed, kind of the first model we trained out of the box took 13 hours to do sentiment, or to train on the sentiment, on Amazon reviews for sentiment analysis. And the reason for this was that actually only one of these computers was working most of the time. So this is the worker utilization for an out-of-the-box model. As you can see, for most of the time, only one computer is doing stuff, and the others are completely idle. This is a monumental waste of resources, and it's the reason for why training took 13 hours overall. However, it doesn't have to be like that. After several weeks of tweaking the configuration of the Spark cluster, after optimizing the parallelism of the algorithms and the distribution of the data, I managed to get much better performance. Let me show you the results. This is the new worker utilization. As you can see, now all the computers are working together at almost full capacity, and overall, training only takes 15 minutes. So we went from 13 hours out of the box to just 15 minutes. A massive improvement in speed that allows you to get to your insights much faster. Okay, so now that we have this working and efficient Spark code at our disposal, let's go and do some sentiment analysis with it. And in particular, let's study some real-world problems in which sentiment analysis is important. One problem that many companies face is that they actually don't have enough label data. They only have a small amount of label data, not enough to train their own model on it. So what they would like to know is whether they can train on somebody else's data and then transfer the model to their own data set. So the question is, how well does this work? In order to study this, we split the Amazon reviews into several categories, or into all their categories, trained on a computer model, and then transferred on the other categories. As you can see, this doesn't actually work particularly well for books, videos, and music. And the reason for this can actually be seen really well if you look at how positive or negative the model thinks certain parts of a review are. So let's do this. Here I have the review. Charming book, couldn't put it down. A model that was trained on PCs has never heard of a charming book before. And it thinks that not being able to put the book down must be a bad thing, because in the PC world, not being able to do something is really bad. A model that was trained on books, on the other hand, knows that a charming book is good. And it knows that not being able to put the book down is good, because that means you're really interested in it. But this doesn't mean that transfer never works. In fact, as you can see, transferring, so training on a PC model and then transferring to software and electronics works surprisingly well. So as long as you ensure that the topic of the data set is similar, you can transfer your model successfully. Okay, let me take a step back and summarize. I've developed a new capability for ASI data science, sentiment analysis on big data. And I've made it as fast and as accurate as possible. Remember how we went from 13 hours out of the box to just 15 minutes. Ultimately, the impact of this is that if you, as a client of ASI, want to monitor your company's online reputation, if you want to extract insights from terabytes of text data, then ASI can help you do this. I can do this quickly and efficiently. Thank you very much.